Alright, so on your screen right now you have John Dalton, who was a teacher in the 1800s. You can see his picture, but he also liked to study meteorology. He was from England, colorblind to red. He liked to write the weather conditions on a daily basis, which is something that he was just interested in. He also had lead poisoning from the drinking water that was passing through the lead pipes in England that eventually killed him. And he is famous for the atomic theory, which is the heart of this section right now. Okay, so here is the theory itself, and it may seem like common sense to us, but at the time it was kind of a big breakthrough. So the first point is that elements are made of tiny particles like atoms, the way that cells are the tiny particles that make up living things. Number two is all atoms of one element are identical, so all gold atoms are identical, silver atoms are identical, etc. 3, atoms of one element are different from atoms of another. So carbon atoms are different from oxygen atoms, which are different from hydrogen, and so on. 4, atoms of different elements can combine to form compounds like H2O for water. Atoms are indivisible, and that word means you cannot create or destroy something, so you can only rearrange atoms like we do in labs. Okay, and this is just a picture of the book that he wrote. You can see the original drawings right here. It's a lot of detail, but this is where he put his atomic theory. Alright, the next scientist is J.J. Thompson. There he is in the picture. If you'd like to watch, this link takes you to how a cathode ray tube works. So in my other notes in open class, you can actually click on that link and see what that demonstration is all about. But here he is. He's an 1890s British scientist, so again from England. He used this cathode ray tube, so here's kind of like a cartoon diagram, but here's what it looks like lit up. And this helped him to realize that atoms have negative particles called electrons. And he originally believed that those electrons were in the atom, sort of dispersed. In the US, we'd probably call it a chocolate chip cookie, but in England it was called the plum pudding model, and this is a picture of plum pudding. It's basically raisin bread in a circular shape, so the raisins were like the electrons, just scattered throughout. It turns out this is not correct, but it was a pretty good thought at the time. Okay, now you have Ernest Rutherford. He's from New Zealand, that's where he was born, but he came to England to do his work. So a little bit later now, 1911, he found the nucleus of an atom through a pretty famous experiment called the gold foil experiment. And again, you can click on this link in my other file and watch the simulation, or copy and paste. So what he did was, he would use positively charged helium or alpha particles and shot them at a piece of gold foil, which is really, really thin. And unexpectedly, some of those particles actually returned towards him. So he knew that they were hitting something heavier, which turned out to be the dense nucleus of the gold atoms. So here it is. Again, you can click on this link to see the simulation. So here's the alpha particle source. Here's the gold foil. Most of the alpha particles went through the foil. Some returned towards him, and that indicated that he was hitting something in the center of the atom, which turned out to be the nucleus. Alright, working with Rutherford was a man named Chadwick, so again a little bit later, 1932. Together they were looking at the nucleus, and they discovered the neutron, or the neutral particle. Okay, so the proton and the neutron make up the nucleus, which is the center of the atom and the heaviest part of the atom. So there he is, and again, if you want to learn more about him, click on the link. Okay, so from this discussion of the scientist, you know that the atom has 3 subatomic particles, 3 parts of the atom. The proton is positive, it's in the nucleus. The neutron has no charge, in the nucleus. The electron has a negative charge and is the lightest particle. The proton and neutron are similar in mass because they do make up that center of the atom, so they're the closest in mass. The electron is the lightest. The electrons are located around the nucleus, and they also determine the chemical behavior of the atom.